That's so true. Haven't been here most of it. SWBA. Paige, what's SWBA stand for?
Students will be able to.
Awesome. Students will be able to use and understand trig functions for right triangles, which is section 8.4 and 5. We're combining in 1 because I really think it flows together very well as 1. And so we don't know what trig functions are yet. We will in a minute here, okay? We will in a minute here. We're going to talk about them. So we're going to go back to our right triangle. This whole chapter is dealing with right triangles. Okay. Did everybody get a calculator? Zach, do you have a calculator? Oh, okay, gotcha. You're just hiding it from me. I see how you be. Okay. So we have this right triangle. Once again, the whole entire chapter is going to be dealing with right triangles here. So if we have this right triangle, and we call this angle A, oh thanks. Okay, we call this angle A. We note it with a capital A because we always do our angles and our points with capitals, our points with capital letters, and our lines and segments with lowercase letters. So the point has a capital letter there. And so we can call the side opposite it lowercase a. We call it lowercase a. Now, we usually try to match them up, though. Whereas if we call it both by letters, we usually try to match up them with the opposite side. So we don't want to call this one A, because it's not opposite angle A. We want to put the one opposite angle A in. Now, is A a leg or the hypotenuse of this right triangle? Leg. How do you know that? How do you, Dominic? Okay. It's opposite one of the shorter angles, one of our non-right angles, right? And it's touching this right angle. Might not be able to see here, this right angle here. Whereas BA, whereas we could call it lowercase c, since it's opposite angle C, is our hypotenuse because it's opposite that right angle. So Eric, what do you think we might call this leg? B, very good, our lowercase b. Now, we have some other ways that we'll learn right now that we can also refer to these legs. But even though C will always just be our hypotenuse, I can just abbreviate it HYP. You might catch me saying hip hop hypotenuse at times. So this leg, we call it A. We can also say it's the leg what compared to angle A? What is this leg compared to angle A? Like where is it compared to our angle A? Opposite. So we can also call it the leg opposite angle A. We can also call it the leg opposite angle A. And I want you to write that in. We can also call it the leg opposite angle A. So what do we think we could call this leg down here? Our B, Jordan? Adjacent to not, so this side, it would be adjacent to what angle? A. Okay? We're skipping ahead of it, but I like it. I'll roll with it. We call this one the leg adjacent to angle A. The leg adjacent to angle A. What's adjacent mean? What's that word even mean? Next to, right? It means next to it. So this leg is next to angle A, isn't it? Now you might say, well, Mr. Kostel, but isn't also adjacent to or next to angle C? Well, how many legs are adjacent to angle C? Two. Two legs are both adjacent to angle C. Both of them are. So if we call it the leg adjacent to angle C, will that help us know which one we're talking about? But how many legs are adjacent to angle A? Just one. Because the other thing adjacent to angle A is the hypotenuse. There's only one leg adjacent to angle A here, where there's two adjacent to angle C. So we want to call it adjacent to angle A, because if we say it's adjacent to angle C, well, that doesn't help us at all. We're like, okay, well, it's just a leg then. That's all we know. But if we say this, oh, we know exactly where it's at. Now, we can also say that this leg, B here, the leg is opposite what angle? B. So we could call this opposite angle B or adjacent to angle A. We could really say either here. Okay, we could really say either here. And we're still talking about that same leg. It is both opposite angle B, and it's the only leg opposite angle B. adjacent to angle A because it's the only leg adjacent to angle A. So we could really call it either. It could be or. Either or. So this could be the leg opposite angle A, or it could be the leg adjacent to what angle? B. Now we have to be very careful there again. So not to say adjacent to angle C, because as we talked about, well, that'd be both legs. Won't help us. But if we call it adjacent to angle B, we know exactly where it is. So make sure we are filling all this in here, because we're going to use this a bit. Before we do, though, I want to talk about this a bit more and say it's all based upon what angle we're talking about. It's all based upon what angle we're talking about here. So if we were just talking solely, only in terms of angle A, if we're talking only in terms of angle A, say we didn't even know this was angle B, and we didn't even know this was angle C, then what would we call this leg? Just the opposite, the leg opposite angle A. And would we, because we wouldn't know this is angle B, we would call it just opposite of angle A. And what would this be compared to angle A? What would this leg here be compared to angle A? The leg that's adjacent, right? And then this is the hypotenuse no matter what angle we're talking about, right? Because it's still across from this 90-degree angle. So this will be the hypotenuse no matter what. But if we just want to get a little more specific with what we call these legs, we can call, oh, this is opposite angle A, and this is opposite or adjacent angle A. And if we said, okay, well, let's say we're actually talking in terms of angle B, and we didn't know angle C or angle A. What is this leg here on the left compared to angle B? Adjacent, not opposite, it's adjacent, it's next to it. And what's this leg compared to angle B? It's opposite, it's not adjacent, it's opposite, it's across from it, not touching. And C is still the hypotenuse no matter what, correct? Has the hypotenuse. Okay, so if we go right below this, you see this in your notes. Everything that's up here right now is in your notes. Now, if we call this a right triangle, right? Right triangle here with the little box there showing us, hey, this is a right angle, 90 degrees. And we have angle A. We can call this the leg what compared to angle A? Opposite, leg opposite angle A. And I'll let us abbreviate that as OPP. I'll let us abbreviate that OPP. Not to be confused with OPPD. That'd be like if I was paying my electric bill. But you guys are too young for that. Yeah. And what would this leg be compared to angle A? Adjacent, very good, next to it. And we can abbreviate that ADJ. The first few letters of adjacent. And what's our third side that we haven't talked about? Hypotenuse. How do you know this one has to be the hypotenuse? It's the one that's left. Very good. It's opposite of our right angle. Okay. And yeah, we could do the process of elimination. We could use that to help us check this too, saying, oh, okay, it should be the hypotenuse, and it is. So we have these different functions or operations in math. Okay, we call them both functions and operations. They're not 100% interchangeable, but most of them that we know are. So addition or subtraction, those are operations we can do, right? Now, if you have different like functions that we've had in like algebra 1, in algebra 1, think back to algebra 1, grind back the gears a little bit there and say, oh, okay, back in time. Algebra 1, we had some different functions. We had like a square root function. We had, we could graph. We had like a square root function. We had like a absolute value function, looked like a b. What did it look like when we had a quadratic function or a square function? Anybody remember what it looked like when we had a quadratic or a square function? Like when there's like x squared. It's kind of like the U shape. It's like a parabola. Instead of a V, it's a U. Or it could be upside down. A U shape. You had all these different functions. Well, just like those, and just like different operations, we have these operations and functions called our trig functions. And they are also operations. Now, our three trig functions are going to be sine, cosine, and tangent. Sine, cosine, and tangent. Now, you can't take sine, cosine, and tangent of just any number. Just like you could take the square root of any number. We can't do that with sine, cosine, and tangent. It has to be taken, you have to do the sine, cosine, tangent of an angle. It has to be taken of an angle. In this case, we'll be talking about an angle measure. But we don't know the measure of angle A right now, do we? And that's okay. We'll just call it A. We'll call the measure of it just angle A right now. So we could take what we call the sine of angle A. That's how we would say this. Sine of angle A. And we could also just abbreviate this. We can just say, we can abbreviate it to 3 letters. You might think, oh, that's only 1 letter off. Do we really need to abbreviate that? Well, it can actually help us quite a bit. Because that 1 letter, because once you get to writing a lot of these, you'll be really happy to write 1 letter less each time. And you'll see this also a lot of places. Now, we will not pronounce a sin. It's not pronounced sin. It's a sin to say sin. Okay? It's a sin to say sin of A. Okay? It's sine of angle A. So even though we abbreviate it, we'll still pronounce it sine. Just like when you abbreviate this, OPP, we still say opposite. Or if we abbreviate the ADJ, we're not going to say adj. We're going to say adjacent. So we'll still call this sine of angle A. Now the sine function is a ratio, a fraction. And it's going to be the length of the leg opposite angle A over the length of the, hypotenuse. So the sine of angle A is equal to the measure of the leg opposite angle A over the measure of the hypotenuse. You would take those measures, you plug them in there, and you would get what your sine of angle A is. The cosine of angle A, we can abbreviate that one as well, just 3 letters. We are not going to pronounce that cos, though. The only time you should ever be saying cos in here is if you're saying my name and saying Mr. Cosol, finishing that out. But we'll say cosine of angle A. Cosine of angle A. The cosine of angle A is going to be another fraction. This fraction will be on the top, the leg adjacent to angle A, leg adjacent to angle A, over the hypotenuse again. This time it's also over the hypotenuse. Leg adjacent to angle A, over that hypotenuse. Tangent of angle A, well, we can abbreviate it. How many letters do we think we'll use in the abbreviation? 3 of them. So we're not going to call it tan. Not going to call it tan. It's still going to be called tangent. Okay, it's winter. We aren't dealing with tans yet. We're still dealing with tangent. Tangent of angle A is still going to be a fraction. This fraction is going to be the leg opposite angle A over the leg adjacent to angle A. Leg opposite angle A over the leg adjacent to angle A. Now notice, like I said, we have to take the sine, cosine, and tangent of an angle. Now, here, is this the same angle A that we're using in all of these in the actual fractions? Yeah, we have to be very careful that we aren't putting like angle A here, and we put like angle B here. We don't want that. We want it to stay consistent. Oh, if we're doing the sine of angle A, we want to deal with the leg that's opposite angle A, that same angle we're talking about. Or if we're doing the cosine of angle A, we still want to do the leg adjacent to the same angle A, not a different angle. Now you might be wondering, well, Mr. Cross, how am I supposed to remember this? Well, awesome, math students, thank you for asking. We're going to remember this with this acronym, SOHCAHTOA. How am I going to remember that? Well, fun fact, a lot of people get out of high school, and like, if they remember like only a few things about math classes, especially geometry, like this is like one thing they really remember, is like SOHCAHTOA. they'll still remember like my brother. He is how old is he now? He's 28. He's about to turn 29 here pretty shortly. Wait, no, he's 27, about to turn 28 shortly. Excuse me. So he's 27, about to turn 28, and like he and I send each other a lot of memes, and he will still send me memes constantly that involve SOHCAHTOA, just because it's like such a popular thing that people still remember from high school. They're like, I don't remember a lot from high school, but I remember this. SOHCAHTOA. It'll stick. We'll get it to stick. SOHCAHTOA. Okay. So what this means, it's an acronym broken into 3 parts. Broken into SOH, CAH, and TOA. How many letters are in each of these? 3. So it's pretty even, okay? It's even there. The first 3 letters, SOH. It's going to be that, not sin, but sign. Sign is, I have to think about exactly how I want to write this first. Sign is opposite over adjacent, or excuse me, over hypotenuse. I'm getting ahead of myself again here. Over hypotenuse, excuse me. Sign is opposite over hypotenuse. Where do we see the S in this? Sign. Where do we see this O? Opposite. Where is this H? Hypotenuse. Sign is opposite over hypotenuse. Now, one way we'll often abbreviate this as we write it, as we'll often write this, is we'll write it how I'll write it here in the red. As we'll write sign equals, because that's is, sign is, and we'll just put the opposite over hypotenuse like that. We'll often put it like that in the red. Because it's still saying sign is opposite over divided by hypotenuse. Cosine is adjacent over hypotenuse. So where do we think the C is in this? Cosine. Where's the A? And the H? Hypotenuse. So in the red, I'm going to write this again here. Cosine equals, and we can just put adjacent ADJ over hypotenuse. And if we look at this fraction again, it's a more abbreviated version, we can see in here CAH. If we kind of read it left to right here, C on the left, and on the right we go top to bottom, A over H, CAH. The first one, SOH. So, and we'll have TOA here. Julie, what do you think TOA is? Very good. Tangent is opposite over adjacent. Yeah, it was. Tangent is opposite over adjacent. Once again, we can write this as shorthand. Abbreviated tangent, TAN, is equals is OPP for opposite, divided by or over ADJ for adjacent. And so do we see here our T, O, and A? And then our more abbreviated one, we still have T, O, and A. So if we can remember SOHCAHTOA, we can remember these. What's the first letter in each of these? That's the trig function we use. The first letter in each of these is a trig function. S sine, C cosine, T tangent. And then from there we say, okay, these are the locations. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. SOHCAHTOA. Does everybody have these down right now? Okay, we're going to work on using these a bit. So, if we go down to example 1, bottom left of the same page we're working on, bottom left of the same page we're still working on here, use orange, feeling orangey on this one, okay? Wonder if I didn't say banana. So if we look, find the sine of angle B, cosine of angle B, and tangent of angle B. So what angle are we talking about here? Angle B. So we're going to circle this angle right now. I recommend circling that in pencil. Not pen, I recommend circling my pencil, not pen. Okay? make sure you do one color for this and all of these, and we'll do one color for the next. Okay, so if you're doing pen, do one color for all of A, and we'll do one color for all of B. Okay? So, if we're doing sine, cosine, and tangent, we probably need to know where our opposite, adjacent, and hypotenuse are in respect to this angle B. So which one of these lengths is opposite? 75, so let's label that OPP here. Which of these lengths is adjacent? 40, so next to angle B. So let's label that ADJ. And which of these lengths is hypotenuse? 85. So now, we need our sine, cosine, and tangent. Well, what's our acronym to help us remember these? Somebody spell that out for me. Paige, I want you to spell the first three. Okay. Dominic, I want you to tell me to spell the second three. Very good. And Jordan, I want you to spell the last three. Very good. So here, sine, well, that's going to be our S. We kind of draw a little line in here. That's going to be our S. So sine is what over what? Opposite over hypotenuse. That means the sine of angle B is, well, what's the opposite length from angle B? We labeled it as 75. And Levi, what's the hypotenuse? 85. So this is 75 over 85. Sine of angle B is 75 over 85. It'll be that number. Now, could we reduce that fraction? Yeah, let's do it. What goes into both 75 and 85? 5. Okay, we see that 5 there at the end. Okay. How many times does 5 go into 75? Not quite. Let's try 15. And how many times would it go into 85? 17. If we weren't sure, how could we check? Could we use the math on our side of the paper? Yeah. Could we also use our calculator? Do we have calculators by us right now? We should. Okay, let's do passes out earlier. The sine of angle B is 15 over 17. So I want you guys to do cosine of angle B and tangent of angle B. And when you're done with those, raise your hand to have them checked. Or if you have questions, raise your hand to ask questions. And actually, I want you to go ahead and do all of the rest A, and then I want you to move on to do letter B as well. I want you to move on to do letter B as well. And when you're done with all of those, the remaining 5, I want you to raise your hand. Or if you have questions, I want you to raise your hand. Put on my blinker. Don't we though? I would love to. It looks good. Yeah. You want to go ahead and do letter B now? There you go. I'll say like when I said that, like that's what you're like, what do you like? Perfect. So if you would just raise your hands. Is that letter A, B, or just A? Yeah. Yep. There's gonna be flipped. Well, cosine of B the same thing as sine of angle A. Yeah. So it'll be. We'll talk about that a bit more. So you found cosine of angle A, so let's find the tangent of angle A. Oh, probably. Let's check first. Okay. We're not checking. Appreciate that.
I got you, Jordan.
I didn't know we had a meeting. Okay, let's focus back up here, please. Thank you. We'll make our way back to our seats. Focus back up here. Okay. Eric, what'd you get for the cosine of angle B?
The cosine of angle B, I got
8 over 17 is what it reduced to. Cameron, what'd you get for the tangent of angle B? Awesome, it reduced to 15 over 8. If we look at B, Julie, what'd you get for sine of angle A?
Like the answer? Or
Yeah, the reduced fraction.
8 over 7.
Okay. Bree, what'd you get for cosine of angle A? 15 over what? 17, I agree. Okay. And then Zach, what'd you get for tangent of angle A?
I got 15.
I agree. Alright, so if we look at these, here, we say, okay, well, what do we notice about the sine and cosine of angle B compared to the sine and cosine of angle A? Like they switch with each other, right? Our answer for sine of angle B became our answer for cosine of angle A. Sine of one angle of this triangle is going to be the same thing as cosine for the other angle. Sine and cosine of the same angle were different, and both sides were different, but the sine of one angle of this triangle is the same as cosine for the other angle. And the cosine of this angle is the same thing as the sine of the other one angle. And what do you notice about the tangents? They just reciprocal from each other. So the tangent of each angle in the same triangle has to be the same triangle for this to work. The tangent of each angle are just reciprocals of each other. Wow, very neat. Okay, question on this one. Okay, let's flip over the page, go to the back here. Yeah. Okay. So some rules we have for using trig ratios is we're always going to circle the angle that is given to you. Is that what we did right away on that first one? Yeah, we circled the angle that was given to us. Now we'll call this the reference angle. There's parentheses there. We'll call it the reference angle. the angle we're going to use to say, oh, where is our opposite? Where is our adjacent? And it's in reference to that angle, in respect to that angle. Now, the angle may be labeled theta. Theta is a Greek letter. It looks like a zero with a line horizontally through the middle, not like a slash, but a line right through the middle like that. It looks like a zero with a line through the middle like that. Theta is a variable that we'll use in math. For us, it's a variable. It's a Greek letter, but for us, it's a variable. Just kind of like x or y, except theta is used exclusively for angle measures. It's used exclusively for angle measures. Okay, we don't use theta for like a side length, but we use it for angle measures. So sometimes we'll say, it might just say, like, find theta. It might just say find theta instead of find x. And it's the same thing, but we're finding an angle measure. Now we'll label once we have a reference angle, we'll label the opposite leg, the adjacent leg, and the hypotenuse. In every single problem. Just like we did on that first one, on that example we walked through together, we'll label these. Every time we'll label them. Then we'll form the trig ratios as our fractions, and we simplify them. Did we go through all those steps already? Yeah, we did. We just did that in the last problem. You guys each did those. So, sometimes we'll have to choose different trig ratios. Thank you. Sometimes we'll have to choose different trig ratios in a triangle. Sometimes we won't know which ratio we need to do, so we have to figure that out. So to look at what we're given and what we need to find, and that'll make more sense here in a second. Once we label these, we'll look at what we're given and what we have to find, and we'll use our abbreviation, our SOHCAHTOA, to help us out here. So if we look down at this box here, in about the middle of the page, when it says use trigonometric ratios, or trig ratios, we abbreviate it, to find sides. So we mark our reference angle. Here, which angle are we given in this triangle on the box? This 35 degrees. We're given that angle. Sorry, that was a little bit of a weird question. Probably could have phrased that better. So we'll look at this angle here, the 35 degrees. That's the angle we're given. We're given the right angle. We want to look at a non-right angle. We want to put it in perspective of a non-right angle. And from this, we'll label the hypotenuse, opposite, and adjacent side. So what's the hypotenuse here? 14. Opposite to 90. What's going to be our adjacent? The bottom that we don't know. And what's the opposite? The opposite one. Okay? We'll stray away. We won't call it short leg, long leg, unless we're dealing with a 30, 60, 90 triangle. But it would be the shorter leg. We would know that. But we'll stray away from calling it that unless we're doing those. But it's going to be, this one's opposite it. So, here, we're given an angle. We're given one side, and we have x on this other side. So that means we're dealing with the angle, we're dealing with the opposite and hypotenuse. So, which of these three, SOHCAH or TOA, deal with opposite and hypotenuse? Have an O and an H. So that means which function does this one fall under? Sine. So we can set this one up as, I'll do it in red here, sine of our angle 35 degrees, sine of 35 degrees is equal to, well, what's the opposite side? X, and what's the hypotenuse that it's over? 14. So we can say sine of 35 degrees is equal to x over 14. So we'll look at what we have. We have the hypotenuse, and we're looking for the opposite. So we say, oh, opposite and hypotenuse, O and H. Look for O and H. So we do sine. That tells us which function to use. That's the only way we knew which function to use. If we were given different ones, we would use a different function, but we were given these. So we use these. Now here, how we would solve this problem, is we say, well, if we want x by itself, it means we need to get this 14 away from it. So we multiply by 14, very good. And if we multiply this side of the equation by 14, what do we have to do with the other side of the equation? Multiply it by 14. Now, when you have like an x or a y or a square root, can you actually multiply the number and the square root of that variable together? Can you like actually combine those numbers and change the number? No, but what do we do when we write it? So let me write it here. So if I have 14 times x, would I change the number to like 15 or something like that? We just kind of push them together, right? And the same thing with like a square root. If it was like 14 times the square root of 2, we just like push them together, right? To say they're multiplying. So we'll do the same thing here. We'll just make this 14 sine of 35 degrees. We'll push them together because sine is a function or an operation just like the square rooting is. And it's equal to just normal x now after we multiply by 14. Now, if everyone takes their calculator, take your calculator right now, please, and thank you. Take your calculator. If you look just above the number 7, 2 buttons above it, what button do you see? Sine. You see that S-I-N, the sine. So that's what we might use here. So to put this in your calculator, you would first type in 14. So have nothing else in there. Figure it out. There's something else in there. Type 14. And then push sine. Or you push times sine because that's the operation that's happening. You're multiplying. You don't have to. You can if you want. Okay? So push times sine or just sine. So everyone should have 14 sine. It should look like this in the light blue on your calculator. And it has a parenthesis there, right? We're going to put our angle measure, 35, in there. And we're going to close up that parenthesis. So type in 35 and close up that parenthesis. And then you can push enter. Okay? So I want everybody to round it. Excuse me, I have to sneeze coming on. If you round it to the nearest hundredth, thank you. If we round this to the nearest 100th, two decimal spots, x would be approximately 8.03. If you didn't get that, raise your hand now. If you didn't get this from typing it in, raise your hand now, please. I want to get that squared away at this moment. If you didn't get that one squared away in this moment. Okay. Now, questions over this process of how we found it, and how we solved, and all of that stuff. Okay. Let's go on to example 2 down at the bottom here real quick. Let's get that for now. Go on to example 2 at the bottom here real quick. A rope takes 20 feet from the base of the building, goes to the roof, and forms an angle of 58 degrees with the ground. We're supposed to find how long is the rope. So I'm going to draw a picture here. First step would be to draw a picture. We have a building. Okay, we have a building here. I'm going to draw some windows in it real quick. And a door, okay, with the hand. Okay? We have a building here. We have a rope going, that's 20 feet from the building. The base of the rope is 20 feet from the building. And it goes all the way to the roof. All the way to the roof. That's a good angle. And what are we told about the angle the rope makes with the ground? 58 degrees. So I'm going to go ahead and label that. What kind of angle would this ground make with the building? Right angle. I sure hope so. Okay, otherwise, we might want to call our architects and say, whoa, 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 whoa. Let's fix this. And what are we trying to find here? We're trying to find the height of the building? Yeah? Is that what it says? Find the height of the building? Oh, how long the rope is? I was getting tricky, so what can we call the rope? X, which is the hypotenuse. So it's our hypotenuse, and we can call it X for now, since we don't know it. So based upon our angle, what side are we given? Not opposite, but adjacent. It's next to that. So here, we're trying to find a missing side length with an angle on another side length. So that means we can use a trig ratio. So we look at this, we're given adjacent and hypotenuse. So in our SOHCAHTOA, which one of these three uses both adjacent and hypotenuse, or and or H? CA, which trig function? Cosine. So we could say cosine of what angle? Our angle is 58 degrees. Is x an angle? No, x is not an angle. X is a length, not an angle. Equals. So it's which one's on top? Adjacent or hypotenuse? 20 over x. Now for here, you have to solve it a little bit differently. Here you have to solve it a little bit differently. Okay. Now this one you have to solve it. First we say we don't want this in the denominator. We don't want x in the bottom. We want to get it out of there as soon as we can. So how do we get x out of the denominator? Multiply by just normal x actually. We're going to multiply by like x over 1 or just x. We have to do that to both sides. And we'll see here why this works. So here on the left we'll just have x cosine of 58 degrees. Similar to how we had 14 cosine of sine earlier. And what happens with this x and this x? They divide out and we just get 20. So now do we have our x in our numerator again in the top? Yeah, even though it switched sides, that's okay. What operation are we doing with this x and cosine? Multiplying. How do we undo it? Divide. And we'll divide by whatever is being multiplied with it. In this case, this cosine of 58 degrees. Mrs. Haswell, would you grab the worksheets that are on my desk on the clipboard? On the corner. They should say 8.4-5. Or /5. So, cosine of 58 degrees divided by itself, which is divide out, and it's going to have x equal 20 over cosine of 58 degrees. Sorry for going into the bell on this one. A short period ran close. Sorry about that. Mrs. Haslam's passing out the worksheet. But while she's passing those out, I want you to listen real quick. You type this in by taking 20, push the division symbol, and then you put in, just type in your cosine button again, punch in 58, and end of parentheses. And that would be it. So when's this going to be due, guys? Next class, which is Thursday. I know you guys ran you up to the bell. If you have questions, study hall before school, right after school. Look at the videos. Here, get one question, buddy. Oh, my bad. You have that makes sense? Awesome. Thank you. Keep it. What's up? Okay. Okay, what's that?
Because I feel like, okay, I don't want to,
Just basic stuff.
yeah, I mean, it's not nice. You know what I mean? Like, and I understand, like, you have to slow down and speed up for, like, some students, but I just feel like a harder one would be better for me. Like,
Are you willing to put in the extra work if you ever kind of lost with the faster pace?
yeah.
Yeah, I think so. Or from what I see, I can see that. I agree with that. Kids are coming in and saying something about that. So what that would be is harder geometry versus the regular geometry. It's a lot of the same stuff, just a little faster pace, and then you can probably be able to eating as well. Here, that makes sense. Awesome, thanks for saying that. Yeah, I appreciate you taking the initiative. Have a good rest of your day. Thanks.
Do you have lunch now or do you have a class now?
We have classes, but I have my plan.
Oh, okay.
Yes, yeah. Although, excuse me, I'll run to the restroom really quickly.
Yes, go ahead.